So anyway, the way we started a long time ago was we were looking at people's contact maps, and we wanted to see if we could do a better job of modeling how people actually think of the people that they interact with. So we created this little app here called the Personal Map. And what this does is this, I haven't entered anybody's name, it sort of automatically figures out who's important to me based on my communication habits. And then it groups people based on who I talk to together. So in this case, who I email together. So you can see here Shelley, the person who worked on this, is here. Her name is pretty big, and she's clustered together with other people in my group. And if I click on Shelley, I could say, well, who else is Shelley related to? And she has a lot of different groups that I talk to with her. So different project teams, the lawyers, you know, people from the university relations team and things like that. So one way that you could use this information is you might want to say, let's say I'm emailing Shelley, and I email Andre. Well, maybe these other people could sort of come to the forefront. So right now, you know that people just tend to either have no contacts in their address book or too many contacts, and it's just hard for me to manage those and to always remember who to include. So tools like this can sort of use your behavior that you use just sort of without even thinking about it, emailing and talking to people, and help you manage that in a very intuitive way. So we took some of these principles, which this really is based on email, and we wanted to say, well, how could we use this in other spaces? We've been looking a lot at blogs and sharing online. So we created this app called Wallop. So you can kind of see some similar visualizations and basically use this same method of sort of inferring who you care about. And we have a smaller, sort of simpler version of the social network here on the left in Wallop. So what this does is rather than looking at who I email together, it says, well, whose blog am I commenting on, or who do I appear pictures with, or who am I inviting or sort of attaching to my blog roll. And as you interact with people, it sort of builds this system for you, sort of a live directory that you can navigate around. And then you can also sort of explicitly say, well, I want Robert to be on my, in my, you know, on my sidebar, or Kevin, and things like that. And I can kind of expand this out and see other people that I interact with, like Rick, my boss, who's sort of in my expanded network. So if I collapse this,
that's why it's a research project.
it is a research project.
If it worked all the time, we'd be shipping it already. Yeah.
Oh well, that's just me. That's the new Seattle Public Library. I stole this picture.
That's your house, right?
That's my house. Well, anyway, one of the things that we're doing right now is we're redoing some of the back end and stuff to actually make it perform faster, but that's not actually happening right now.
So this is a project about looking at sort of small working groups and not sort of the big, you know, Friendster, Orca kind of, you know, networks of everybody in the universe.
Thanks.
I mean, we probably shouldn't take up too much of your time because you're like super busy.
All right. Well, there it is.
Lily.
So thanks
You're
for
a
coming
network
by.
of one.
Yeah, my network of one. One friend.
Yeah, you only have one friend. That's because you haven't invited me yet.
Yeah, it seems you better rob her. Everybody will be there.
Invite Mark Kenner, you'll have 800 friends.
Hey, thanks for your time.
Okay. Thanks, guys.
Bye.
Okay. Why don't we head on downstairs to the hardware lab? Because I think that'll be a fun place for us to visit. Okay. It's kind of funny you ask, why would a software company, a software research group, have a hardware research lab? But it's actually super important to us. We try to track all the latest trends in hardware so that we can understand what kind of software we would need to build for those systems in the future. So we have it's pretty amazing people working on hardware research. It's actually a small group, it's only about 4 or 5 people. But one of the guys we're going to meet downstairs is Gary Starkweather. He back a while back, he was working at Xerox PARC and he actually invented the laser printer while he was there. And we have another guy down there, Mike Sinclair, who works with this technology called MEMS, Microelectronic Mechanical Systems, which is using the fabrication process we use for silicon chips to make very tiny little moving parts, but do it very cheaply and do it in very large quantities. So we're going to be meeting with them.
Excellent.
We're in the cafeteria here. It's about lunchtime, and one of the cool things about our cafeteria here is we get a whole bunch of our research together just to eat lunch. And so this is a group of our hardware and graphics researchers together. This is Turner Woodett. He heads our hardware group and our graphics group.
Yeah, I'm not going to be able to hear anything you're saying.
I can't hear anything I'm saying. This is Jim Paggia. He's one of the directors of Microsoft Research here in Redmond. And
Cool.
looks like they're just finishing up. Was lunch good today? Okay, we're just flipped over the next building, and we're coming right up. Hardware lab right here. So if you sort of peek through the window over here, probably go inside there in a minute. That's their shop where they actually can build pretty much any kind of enclosure they need for some of their hardware prototypes that they do. It's kind of a cool facility to have, really handy for them, so they don't have to send things out to go get other things done, and to just build sort of enclosures for the little things they do. So to come around here, let's see if anybody's home. If anybody's in the lab, maybe they're in the offices. Let's see. Mike!
Kevin.
This is Mike Sinclair.
Oh, there's a photographer again. Okay, you got film this time?
It was Mike Sinclair. He's one of our hardware researchers. He works on MEMS kinds of systems. You have a minute to show us some stuff in
I
the
think
lab?
Gary's in too.
Let me see if I can
Cool.
find Gary.
Go ahead.
Gary, you want to join us? Right here. Okay. We'll be in the lab.
Okay.
All right.
This is the hardware lab. These guys have the best toys.
So you're doing research on hardware. What
Yeah.
kind of hardware?
User interface devices.
And
This is where a lot of it begins.
okay.
This is the ultimate sterilized, ultra clean model shop. We have a 5-axis milling machine over there, computer controlled.
Wow.
Good to 2.5 micron resolution. And behind you is a computer controlled lathe. And then over to the left is a computer controlled laser cutter that cuts out bits and pieces of plastic. And it's very, very simple to use. We can cut out gears and wheels and springs. A whole bunch of neat things. So anything you can dream up on Visio, you can cut out in plastic. And so a lot of folks around MSR come and use this, and literally they spend maybe half an hour and they go away with whatever widget they design.
What kinds of things have been designed on this machine?
Oh man, camera mounts, flexible circuits, here's a little camera panner. I don't know, whatever the normal software types, they may need a quick something. You see a lot of camera mounts or microphone mounts or whatever.
Right. Now, do the mice and keyboard guys come and work with you guys here, or
No, they have their own shop.
they have their own
And
shop?
They're thinking about getting one of those things.
Yeah, that's pretty cool for one of them.
Mhm.
Yeah. Could build any kind of mouse you want.
And over here is Gary Starkweather. He's a resident optics expert who did a lot of early
He's
work
trying to
on the laser printer, but has now been really working hard on display kinds of technologies.
And you invented the laser printer, is that true?
That's correct. That's correct.
He's very modern.
I remember it before it was popular.
And you did that at Xerox PARC?
I did that at Xerox PARC. Right.
And tell us a little bit about that process. How did you come up to invent the laser
Well,
printer?
it's an interesting story. I was at Xerox in the early 60s, and Xerox had a very novel product that it made. Never went very far, but it was a very novel product called LDX, long distance xerography. And they used a cathode ray tube to both scan a document and to print with it. The trouble is it wasn't very fast. It just couldn't, not much you could do to extend it. So I took a look at the problem and said, you know what you need is a brighter light source. Well, 1964, brighter light source called a laser. But it was very primitive. I mean, at this point in time, they were there. So I decided to do some work on trying to improve that. And partway through, it dawned on me, why do we make a fax out of this? Because I can modulate the laser. Why don't I let a computer generate the originals? And then we wouldn't have to have any originals, and we could send originals by wire. So that's where I got the idea. The idea fell on very deaf ears. And fortunately, Park formed, and it was a island I could escape to and still work on it. And when I got there, then the Alta was coming along doing bitmap screens. They needed some printer that would turn bits on and off, and the two came together just perfectly like a fish in gills. And so Park was a very good home for that, and that's where it got started there.
How does the Microsoft research compare to Park?
Microsoft research is very much open, like Park was, and one of the biggest benefits we have is we have very business-savvy management here. So you don't have to explain sunrise and sunset to people here. They understand, and they have a real desire to move forward. And the kind of research we're doing here is much in league with what Microsoft is working on. Xerox created Park to be very different from what it was currently doing. And when we did things really different, they didn't know what to do with it. Here, I think we have very savvy people who know how to deal with it. We got people like Kevin, for example, who know how to work with the business types and help translate the strange contraptions we come up with into things that they go, oh, that's what they're trying to do. So I think it provides a good communications aspect in which research has an outreach through people like Kevin's organization, as well as very smart management who understand what we're trying to do and want to drive the business forward. Park was almost an oasis. It was those of us who had these strange ideas. It was a place to put us out on the West Coast and hopefully quarantine us out there so we didn't infect the rest of the company.
Interesting. In 10 years, what are we going to be talking about? What you invented this
Big
decade?
displays. Big displays. Everyone's going to wonder why they ever worked with these portholes that they worked with before. It'd be like houses with 1 square foot windows. And somebody's going to say, why didn't you put picture windows in there before? That's what I think we're going to see, because the information explosion is going to require a lot more displays and updating of it. And we're going to have to, our walls will turn into information surfaces rather than just paint on them.
Wow.
Can you show us a couple of things you have on the benches here?
Sure. So here, for example, we're trying to look at one of the other aspects. Let me describe, I think, the 3 wonderful characteristics of human vision. There's color. And everyone says, well, that's obvious. It was not obvious. Less than 10 years ago or 15 years ago, it was a career-limiting move to suggest anyone actually use color. No one saw the value in it. So it gradually got crept into displays. The other thing we have is peripheral vision. That's what the big displays are all about. And the next thing is, why not use both eyes? And so that's what we're trying to do with 3D. And so we both build devices as well as evaluate other people's products. And we have a big plasma panel over there that's got some 3D structures on it built by a company called X3D. And we're looking at the work they've done so that you would have stereoscopic television, this sort of thing, which gives you the ability to see more detail, find it more interesting, more entertainment value, that sort of thing. So what we're really trying to look is to say, we've got a lot more computing power than we ever had before. Let's use it to drive the display and make this visual system. And I guess pretty much psychologists tell us that 85% of all the data we take in comes through the eyes. So we should really enhance that channel.
Is there a day coming when the computer can look at an object and instantly recognize it the way our
Well,
human
I'd like
brain
to
can?
think so, but certainly I think it's a ways from my grandchildren who can look at the back of their mother's head and recognize her. So I would think that there will be some form of that that comes along, but I think we're a long way from anything human-like, simply because, I mean, if you think of the billions of brain cells, the estimates are by Harvard Medical that over 50% of the mass of the brain is dedicated to vision. So we got some work to do.
Are you working with like automobile manufacturers to do assisted vision?
We have not personally done that, but the kind of work we're doing in which we think that would certainly be valuable. I just bought a car that has a backup camera in it, and it is wonderful because now when I back up, it's just so much more reassuring to know that I can see what's behind me in that regard. And now if the car could sense that and sense that there's something that it recognizes there that's questionable, it could also alert me in that regard. I think that's the next step.
Right.
Can we take a step around the
Sure.
corner and see some of the MEMS stuff?
Sure.
So Mike's well, the nice thing about our hardware box is we sort of set it up so that Mike and Gary have big spaces here, but there are other researchers who can come in and get some bench space too. So this is Mike's area over here where he works on MEMS technology.
What is MEMS technology?
MEMS is Microelectrical Mechanical Systems, Micromotors, and probably some of the more common products you're familiar with are TI's digital mirrors, which invade a lot of the innards of modern-day projectors, and almost all airbag deployment transducers, the things that when it undergoes a certain acceleration or deceleration will charge your airbag, and those are little micro motors in the form of accelerometers.
And these motors can't be seen by the human eye, can
That's
they?
right, they're just too small.
Wow.
And
Who discovered that they could build little
I think it
things
was a
on
long
silicon
time
die?
ago. Probably something wasn't nailed down in a piece of electronic silicon, and they saw it wiggling, and the rest is history. But here are some MEMS chips. These are the raw silicon chips.
Now, how many micromotors can be on one of these chips?
You can probably get 10,000 or more on it. if you wanted
10,000
to.
on one of
Yeah.
those chips.
Now, this is actually a prototypical fabrication process that we use in North Carolina. So what I do is, over the period of a couple of weeks, I'll design, this is just one chip, I'll design 1 square centimeter worth of silicon real estate, and I'll design a whole bunch of experiments. And this particular chip was to evaluate one-dimensional and two-dimensional scanners. And I draw this on a drawing program, much like your favorite 2D or 3D drawing program. This happens to be a product called L-Edit, which is mainly made for MEMS, and all the different colors are the different silicon layers that you can then have fabricate.
Now, how many man years or how many hours took to develop that?
I probably spend 2 or 3 weeks on a chip. Then we send the CAD information off to the fabrication house, and then 12 weeks later, they send me 15 identical chips.
Right.
Then I take these chips, put them in what they call a probe station right here. And then observe under the microscope as I manipulate these microprobes in X, Y, and Z. And I'll either wiggle things that need to be wiggled mechanically. I'll inject currents or voltages, or I'll read currents or voltages off the MEMS device. And so I'll program up some sort of simple electrical circuit here. There's a computer down there to stimulate and to read various voltages. And then I'll make electrical contact with the various pieces on the MEMS chip with these micro probe devices. Find out on the oscilloscope or actually hit the mirror that I'm wiggling with this laser, and then it hits the mirror down on the chip, and then will reflect up to my screen up there. And as you see on the screen, these are some videos of some of the devices I've got to.
Now, these are your devices.
That's correct. These are all my devices. That's a focusable mirror. This is called a scratch drive actuator. It's an electrostatically driven inchworm kind of device. And here are the same devices, only around in a circle. And each step of that electrostatic stepper motor moves 25 nanometers, 25 billionths of a meter. And just gives you, in your physics class, if you can harken back that far, you remember the equation F equals ma. So what happens if you make m really small? Well, you can do amazing things if you make m really small. And you can get things to wiggle very fast or with very low voltages, very low currents. You can read minute changes in position. The devices that you see on the movie now, these are thermally actuated MEMS devices. So I'm actually heating and cooling little polysilicon beams very fast. I can do that 15,000 times a second and heat and cool them, and using the positive temperature coefficient of expansion, or when they get hot they expand, turn this into some sort of usable energy, mechanical force. And specifically now, Gary and I are looking at display mechanisms. I'm looking at a MEMS-based projector, much simpler than Texas Instruments micromirrors. This actually will take three collimated on-chip red, green, and blue laser beams and actually deflect them in real time to create a video raster.
Wow.
And then we're looking at making, just for a couple of dollars, a little projector about the size of my thumb. And then now take this, and this projector is responsible, say, for a couple of square inches of a larger piece of image. And then literally solder these things together on a big printed circuit board and make a display as big as you want. So we're looking at kind of a tileable entity for solving very large displays.
You can make lasers that small now.
Mm-hmm.
Wow. And how bright? You showed me a video before where you could actually read words from
Right,
one of the
right.
lasers.
Those kinds of lasers are probably a little brighter than the little laser pinpointers you can buy. But one laser pinpointer is not enough to illuminate a whole wall. But what if it's just to illuminate a couple of square inches? It's plenty bright. And then you had all the neighbors do the same thing for a seamless display. And that's what we're looking at.
So would these chips be behind a translucent layer?
Exactly.
That would...
It'd be maybe like a plasma panel, maybe a couple inches thick.
Wow.
That's it.
Wow.
And hopefully for less than national debt.
Now,
Make them cheap.
how many years are we away from seeing something like this?
That's a good question. There's Gary and I working pretty much part-time on this, and we're hoping our partners, people who really know what they're doing in the display business, are looking at this also. We're not getting a big hint that they have the manufacturing technology that goes beyond, say, the plasma and the LCDs today, because those are essentially one device for all pixels. They have to make literally an integrated circuit as big as the display. Manufacturing problems are horrendous for that. So we're looking at breaking the manufacturing problem up into smaller, bite-sized chunks.
Right. Would you take a call from like Sony or ViewSonic or
Sure.
work with anybody in the
Absolutely.
industry?
We're already talking to our partners, our friends in the industry, and they're very much interested in what we're doing.
Great.
Of course, they don't want to instantly turn down a multi-billion-dollar fabrication run just on a new technology, but they're, of course, very interested.
Hey, Mike, thanks for your time.
Yeah,
Thanks.
thank you.
Appreciate it.
This was awesome. Thank you.
Okay.
All right.
So when you need a tape free, let us know.
No, this one's going to work. If it doesn't, I'm going to jump off the bridge.
So that's our hardware round. Oh, there's Eric Brill. Eric, don't run off. Eric, don't run off. This is Eric Brill. He's the lead researcher on natural language technologies and search technologies.
Oh, wow.
We'll interview for Channel 9. It's going to go out. Have you seen
What is that?
channel9.com yet?
No.
channel9.msdn.com.
What is that?
It's a site for developers.
Oh, I do know what
see-
that is. Yeah.
Yeah.
Oh, you're filming things?
We're doing
Oh, yeah.
a walk-around tour of NSF.
Oh.
So Eric is one of our rising stars in the search area, done a whole bunch of interesting. See, now I'm making him blush here.
Not that last part.
He's been working super closely with a number of product groups around Microsoft on search issues, particularly closely lately with MSN search. You can see in the stuff they've been launching lately, a lot of the good work that Eric and a whole bunch of other Microsoft researchers have been doing with it.
That's dramatically better. What kinds? I'm not even sure what I can ask you that you can talk about, because obviously you're working on a technology that's very competitive with Google, right?
Right.
What kinds of things over the next couple of years do you expect people to be able to do with search that they're not able to do today?
It's actually being filmed right now.
Yeah.
I have to think on the spot here.
That's right.
I actually think on the spot. So one obvious thing is question answering that we're working on. So being able to, who do I gotta look at you? I don't know.
Me.
Okay. So being able to ask questions of the web and get answers back instead of just getting a bunch of web pages back. I think the most exciting thing is probably that what things look like in 2 years from now will be completely different from what we think things will look like in 2 years. So just being ready to kind of anticipate how can we unlock all the value that's out there on the web that we haven't figured out to unlock yet.
Wow. Are you looking at doing searches of RSS feeds?
My group isn't specifically.
Okay. Because one of my favorite new features on the Feedster search engine is when you do a query, it can build a search feed. So like I search on Microsoft Longhorn, and anytime somebody on the web writes about Microsoft Longhorn, it comes into a folder in my
Yeah, that's very
Outlook.
cool.
Yeah, I hope you guys do something like that.
Yes, a whole bunch of equally cool things that hopefully we'll get to see real soon.
Yes.
Yeah.
Hey, thanks for
The
your time.
MSN's dramatically better, so keep it
Yeah.
up.
Thanks.
All right.
Yeah, search is a super interesting area. We probably have altogether 25 to 30 researchers who are working on different aspects, whether it's really low-level distributed systems kind of work on how you build very scalable indexing and search front ends, every step of that. New user interface, paradigms for search. Eric spends a lot of time looking at sort of statistical and natural language approaches to search. A whole bunch of other cool stuff. I mean, it's really funny when you think back. A few years back, before really Google started rising, there were a lot of people who thought that Alta Vista was the be-all and end-all of search engines, right?
Yeah.
And, it did everything you need, and why would you ever need anything better? And then Google came along, right?
Yeah.
And and it's funny to sort of hear the same talk again from a lot of people. Like, well, Google gives you everything you need. What more would you need, right?
Yeah.
We're just going to keep making it better and better. There's so much more we want to be able to do because, today, sort of like what Eric was saying, we have questions, right? And you go to one of these search engines, and they don't answer your questions.
Yeah.
They just give you a bunch of documents afterwards, right? What you really like is something that's actually going to answer your questions.